So we're now going to take a look at using the RxJava single class and some of its basic operations in the context of an asynchronous example. Previously, we'd looked at one that was synchronous, and that was interesting, but it doesn't really show off the cool features of RxJava and singles. So as you can see here, there are 3 method references that are registered with the main program using the Async Tester framework. We're going to register something called test fraction reduction async. And then we're going to register 2 method references that are test fraction multiplication callable 1 and test fraction multiplication callable 2. So those are 3 different methods that are going to run. And let's go ahead and start running them just for kicks. And you'll see that they start running in the background. And something that's worth noting here, you can see that we're printing out the threads where things run. And if you went back and looked at the previous examples, they all ran in the main thread. They all ran in thread 1. And now they're going to be running in other threads in the background. Some of them will run in the foreground, some will run in the background, but things can now run asynchronously, which is going to be more powerful, as we will see here in just a second. So let's go ahead and close that window. We'll come back and look at that in just a bit. Once again, we'll talk about the Async Tester framework here shortly. So let's go over and look at the actual class. This class, as I mentioned before, shows how to use RxJava to asynchronously reduce, multiply, and display big fractions by various single operations. And these are basically the same ones we looked at before in the previous example from ex2, except now they're going to run asynchronously. So let's see how we do this. Here is the test fraction reduction async method. And you can see what it does. It looks very much like one of the methods we had from ex2, where we put all the computations in local variables. We have a big fraction, which is going to be used kind of to store the unreduced big fraction. We have a reduced fraction callable variable that will reduce the big fraction. We have a convert to mixed string variable that uses a function to print some diagnostic information and then convert the reduced fraction into a mixed string, creates a proper fraction out of an improper fraction, as they say. And then here's the actual code that's the single chain. And you can see that we start just like we did before. We say, I want to do a callable. I want to take this reduced fraction callable, which we have up here, and I want to start the reduction. But now things get different. And if you take a look here, you can see what we're doing is we're calling the subscribe on method. And what subscribe on is doing here is it says, starting here, do all the processing from here down to the bottom in a single background thread. So all that computation is going to take place in the background. And again, it doesn't matter whether we put the subscribe on here or after map or after do on success. It's not going to change the behavior of the program. So what happens after that occurs, then we're going to do the from callable in the background. We're going to do the convert to mixed string in that background thread. We're going to do the do on success, printing the result in a background thread. And then the final thing we have here is a call to ignore element, which is really just a way to tell the async tester framework, don't return until all these computations are done, in which case that final step will be run, which will trigger the async tester framework to know that we've finished that computation in the background. And lo and behold, if you go over here and look at the results, you can see that all these computations take place in the background thread. So that's thread 23. Okay, so let's go ahead and skip back over here. And let's go down and take a look at test fraction multiplication callable 1. And this is going to test sort of a hybrid async model using a single and a callable. And the processing is going to be performed in a background thread, but the result will be printed in a blocking manner by the main thread. So that's why if you take a look at the results from here, you can see that they come out in the main thread of control. Okay, so let's take a look at how this works. We have the call local variable, which is going to be doing the big fraction multiply. And here we go ahead and convert that callable into a single by using the from callable factory method. Then we use subscribe on. So this says this processing will take place in the background in a single thread. So now we've got ourselves a single that's going to be doing the computations in the background. However, look what we do here. We say single.blockingGet. And what that does is that blocks the calling thread, which in this case is the main thread, thread 1. And it won't return until the background processing is done. So the processing is done in the background, but the actual result is going to be printed in the foreground. And you can see that we print it right here and display it. And because we're all done at this point, we return an empty single. And if you take a look over here, you'll see that this is just a completed completable. So this is a little bit like having a completed future, if you will, from the completable futures framework. So this is just a way to tell the async test framework, no need to block, we are done. All right, so then here's another variant of this, except in this case, all the processing is going to take place in the background. So again, we're going to do the big fraction multiplication here in the background. When it's all finished, we're going to print the results, and we use the ignore elements or ignore element method. And you can see when that thing runs, it does the same computation, except now it does it entirely in the background thread. So all the processing gets done in the background. And that, by the way, is why we're using the string builder, because we need to make sure that this gets done in the background. And so it's going to be displayed in the background. And that's why we need to use the string builder, because we don't want it to write directly to the user, which will show up in a different place and cause confusion. And then here are just these little helper methods, print result, which displays the result. And there's a couple different versions. One takes a big fraction and stores it into a string builder. The other takes a mixed string and will display that into the string builder, and so on and so forth. Okay, so that is basically showing how these methods work. And the only real difference between this piece of code and the one we looked at in ex1 was that this one's running things in the background using subscribe on. And now that we've talked about that, let's go turn our attention briefly to Async Tester. So this will give us a chance to talk briefly about what Async Tester does. Now, some of the things in here will be talking about more advanced features we really haven't covered yet, but I want to give you at least a high-level overview of what's going on, and we'll probably come back later when we've covered these other advanced features so you can make more sense out of how Async Tester is working. So recall what we use Async Tester for. We register all these asynchronous computations, and they're then going to go running in the background or the foreground or wherever they run, and we want to have a single place to wait for all those computations to finish, because we can't just fall off the main program, because that would shut the whole process down, which we don't want to have happen. So what we want to have happen is we want to run all those tests asynchronously and only have this call return after everything else is finished. So here's how we do that. So you can see here the Async Tester is a class. It has basically a list of suppliers to completables. Completable is just a RxJava mechanism that will signal or will give a result when something is finished. It signals at that point or fires. We have a register method, and all this method does is it just adds a supplier to a completable to the tests list. Very simple. That's what happens when we register things. So if you go over here, you can see that we register this stuff, and it's just registering those method references, which are suppliers in this case. And then here's the run tests method. So you can see that the run tests method is going to go ahead and take this list, the one we had up here, list of suppliers to completables, convert it into an observable. We'll talk more about what observables are in a second. Observable is kind of like a stream. And then we're going to use map. And what map's going to do is for each of those suppliers, it's going to go ahead and call the get method, which will then start that asynchronous computation running. And this returns something called flat map completable. And we'll talk more about flat map completable later. Flat map completable basically converts a bunch of observables into a completable. And you can see here that we end up with a single completable. And this is kind of like the all of method that we have in completable futures. Basically what we're doing here is we're saying, let all those things run in the background. And when they're all done, then give back a single completable. And when that single completable comes back, then we're going to go ahead and convert this into the number of tests we just ran. So completable has a method called toSingleDefault, and we can go ahead and say, give back the number of tests that ran when the final operation completes. And this will come back as a single to a long, and you can see how we used blocking get to wait for that to finish. So that's a very quick overview of Async Tester. Again, some of these things we'll cover later. We'll cover observables later. We'll cover from interval and map on observables later, and we'll cover flat map completable later as well. But I just wanted to give you a brief overview of what we're doing. And the big idea here is that we can have all those asynchronous computations running in the background and then have a single place we can wait for them to finish. So it's a little bit like the collector that we had with Java streams and how we used the collector in conjunction with our futures collector stream, which collected things up into a stream or into a list or whatnot.